How are you, everybody who is watching this video? My name is Olenjolaim TAYAI single from beautiful, fantastic country, Tanzania, eastern of the African continent. I'm very happy to have you today in this fantastic moment, and I would like to take this opportunity, whether you're an international viewer or national viewer, just to keep on enjoying, because you have a so good news in order to take you from one point to another point, because that responsibility would like to add value in your life. We'd like to welcome you into our online Diploma Polytechnic Institute of Tanzania in square bracket OLENJOLAI. Simultaneously, we'd like also to welcome you in one of our YouTube channels that's called Online Diploma Polyinstitute of Tanzania in square bracket OLENJOLAI. Wow! So this is the fantastic online institutions where that we are training and teaching students, and actually that we are mentoring them and incubating and teach them how to think differently in order to act differently. Because once you think differently and you change your way of thinking, then you act differently. And that's what even ourselves, that we are a product of what we are telling you right now. So we are very happy to have you, as I said. And I would like to remind you quickly the vision that we have in Online Diploma Polytechnic Institute of Tanzania in square bracket OLENJOLAI, as well as this is very important information for you to remember every time, even ourselves also, that God remind us, because He's the owner of this program. So what visions do we have in Online Diploma Polytechnic Institute of Tanzania? So we have a responsibility to teach, to incubate, to train, to mentor, and even to lead some students who will be ready to take their classroom instructions in ordinary diploma knowledge. It means that for both contents, for the fundamental courses and also for the core courses, to combine that knowledge from the classroom education with the knowledge of Word of God from the Holy Bible in order to solve real life problems. So that is the visions we have in this platform. Our main goal is to see our basic technicians who are still at college, whether first year basic technicians or second year basic technicians or third year basic technicians at Tanzania. We call them NTA level 4, NTA level 5, NTA level 6 of engineering and scientific careers, that they are solving real life problems, even if a small scale real life problems, because that's why we went to school, in order to have knowledge, to have understanding, to have a skill to solve our real life problems. I know that what I'm telling you, it might be sounding like impossible. So even myself, when I heard this voice personally, because I'm a product of both scenarios. I'm a product of the Word of God from the Holy Bible. I'm also a product of the classroom instructions that by using the educational systems of Tanzania. But right now, I'm solving a real life problems. So this is my solutions to solve real life problems existing for the present and future generations. What real life problems mean? That what solutions am I providing? Teaching. What is the problems? People, they fail to understand this stuff themselves on their own. So somebody has to stay, somebody has to take to be in charge, arrange and simplify the contents so everyone can take them in easy and even interesting way. So that is what we have to think in our mind. So we have some specific objectives in this platform. We might be concentrating on training, on teaching you the classroom instructions, because we know your primary stress is just you fail to master your classroom instructions. So because you fail to master your classroom instructions, you will fail to think outside the box. It means that the problems, real life problems in your community, need the knowledge that you are acquiring. So our first responsibility that God has given us as one of our specific objectives, we have to make sure that you love basic engineering and scientific mathematics. That's one of our specific objectives. And our second specific objective, you master it. It means that in basic scientific and engineering mathematics will never be a problem for the rest of your life. Right? That's the second specific objective. But the third specific objective, we are going to help you to master, it means that to perform well or to do well in a continuous assessment, not even having the minimum required marks for you to just to succeed in a continuous assessment, but you can even have, or you can get even the maximum marks for your continuous assessment, right, of your course. So that is another specific objective. But our fourth specific objective also, we like to see that you do your annual exams, or we call it end of semester exam, successful and even with a high pass mark. But against number 5, our specific, another specific objective, you have to think how will you apply these concepts that we are teaching in basic engineering and scientific mathematics in your particular course, in your particular program, in your particular we call it in a particular department, let's say, so we have different names that we can call them, but I think that you got the point. So that's another specific objective that we have in this platform. Remember to subscribe because we have some of the departments in online Diploma Polytechnic Institute of Tanzania, and one of the departments is called Basic Engineering and Scientific Mathematics, where we are right now. And these departments currently are teaching 6 courses or 6 modules. So we expect you to have more than 300 videos in this YouTube channel. So make sure that you subscribe and you watch also previous videos and watch these videos several times as well as you can until you master every concept and OMT for you. So we think that one of the courses is called Fundamental Rule of Counting, Matrices and Differentiation. Possibly you are watching these contents in any of the African country, or maybe in Europeans or in North America, or you watch these contents from Middle East or from Russia, from China, from Indonesia, from Malaysia, from Sri Lanka. So regardless of where you are in the world, the concepts of I'm going to teach you the fundamental rule of countings are the same. So for example, that in lecture 4, I'm going to teach you permutation. This is a universal concept worldwide. Every student has to know, every student that study mathematics has to know ABCD of permutation, so that maybe the course in your institutions or in your college is not named like this one, but the issue is you should have the course outlines so that you understand what you should cover, because we want to help you regardless of how far you are. So then let me do the quick review to link the previous lectures with today's lecture. So this is lecture 4. I would like to teach you permutation. The National Ministry of Technology, this course is, or this module is taught in the first semester of the second year. So if you're studying at the National Ministry of Technology, then you have everything in your hand right now. That's the good news for you. Okay, but these contents are not limited for the National Ministry of Technology only. I just use the National Ministry of Technology just like a reference for all the institutions that providing honor diploma in Tanzania. So we have already posted lecture 00, which is titled as General Introductions of Basic Scientific and Engineering Mathematics. And also we have another one, which is lecture 01, and this one is titled as okay, it has been titled as factorial function. And also we have posted lecture 02, when that you've been solving problems of factorial functions. And then the previous video is all about lecture 3, and here we've been solving what? We've been solving factorial, let's say factorial equations. So we have solved this, I solved in 3 factorial equations that are titled as example 8 to example 11, and then I left the homework. I left the homework, which is homework 3, and I left that was example, this is to 10, which was example 11, and also example 12. So did you do the homework? Let me know, please. Did you do the homework? Okay, did you do? So have you submitted? I didn't see. Okay, so we may do corrections for one question, and then we continue today's session, and this will be enough for you to review. Okay. So okay, so it means that one question is this one. So this was okay. So this is example. It was example 12. Can I do, for example, 12? For example, okay, yes, let me do, for example, 12. So example 12 was asking that find the value of A. Value of A in 4 factorial, and then have y factorial divided by what? Divided by y minus 1 factorial, and then you have what? 12y. This one is equal to A. So, well, so it means this is the question that I gave you. Find the value of A. We have 4 factorial, y factorial. Here you have 1 minus 1 factorial, 12 factorial. In case that you find, I'm solving this problem quickly, then you have to make sure that you review this video several times as well as you can. Okay? As you can. So we say that you have 4 factorial, y factorial over y minus 1 factorial, then 12y, right? Okay, 12y. So let me check. 12y. Is it 12y or 12y factorial? I want to be sure before I solve it, because possibly that I can solve it while I'm solving a different question from the one at 12y. Solution. So as I told you, the first step always, once you want to solve these questions, we say that inspect equation 1, right? Inspect equation 1. So to inspect equation 1, we have the numerator and denominator, right? So if what the relationship between these factorial functions, 4 factorial itself, it does not have relationship with n, but y factorial is relating with this denominator, right? So what is the relationship? If you expand this y minus 1 factorial, we will never get y. But if you expand y factorial, we will get y minus 1 factorial. So it means that y minus 1 factorial is a subset of 40 of y factorial. So it means that the first step is respecting the equations 1, okay, especially on the left hand side. So we find that y minus 1 factorial, not y. Okay, yes, y minus 1 factorial, this is a subset. It's a subset of 40, it's a subset of y factorial. Okay, so it's a subset of y factorial, then what do you say? You say fine. So we say we go for the second step right now. The second step, we say that we have to expand it. Let us expand y factorial. So to expand y factorial, this will make it y factorial is equal to y minus 1 factorial. This is enough, and this will make equation 2, right? So we go for the third step. The third step, we say that substitute equation 2 into equation 1, right? Into equation 1. So substitute equation 2 into equation 1, then we have what? So we have 4 factorial, and then you have y, so it will be y, and then times y minus 1 factorial divided by y minus 1 factorial, and then you have what? 12y. So this is equal to a. So this one and this one will cancel, right? So if it will cancel, what do we say? We say that it remains is 4 factorial times y over 12y. This is equal to a. So a, which you have to find, is equal to 4 factorial. 4 factorial is equal to 4 times 3 times 2 times 1 times 0 factorial, and then times what? Times y. And then it's divided by what? Divided by 12y. Okay, a factorial is equal to what? So this y and this y will cancel, and then it's 12. Okay, this is 12 over 12. So it means it's 2 times 1 times 0 factorial, which is equal to 2. So therefore, the value of a is equal to 2, and you are done. Did you get it? Tell me in the comment section if you are right. And congratulations if you have got that question. Congratulations. May God bless you. You're gonna get it. You're gonna solve so many questions and you'll get the right answers. May God bless you. So let us go to today's sessions, which is permutation. Say again, permutation. 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 Say it. Permutation. 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 You can construct it and can formulate it and call as permutation. Permutation. Remember that these are we call the principal rule of countings is kind of general introduction for the probability of advanced mathematics. or even basic applied mathematics. That these are very important concepts that we need them in real life in solving problems. Because for example, that maybe we have 11 players, right? You are watching football, you like Manchester, possibly like Barcelona, right? And then for instance, at Barcelona, or maybe for Simba Sport Club, possible that it has 11 players, 18 players who have to participate, who have to play, maybe 11 players or more than 11 players have to play in a particular game against the younger, you see. So it means that these 18 players, you have to think there are so different ways that they are going to sit on the bench, right? Or even if they want to take a photo, there are so different ways that they can take. So similarly, even if ourselves in our daily life, we are arranging things, we are arranging objects, whether in cycles, we are arranging furniture, we are arranging millions of these things in our daily life. So that's why that the concepts of factorial and the concepts of permutation and the concepts of combinations are very important in real life, right? So once that I'm teaching you all of this piece of information, think that how you can apply them to solve a small scale particular problems in your family, because in your family they are waiting fantastic and interesting solutions for their daily problems, to know that now we sent a son or we sent our daughter into college in order to have knowledge. Okay, so you have terms we call it permutation. So the fundamentals of, let me write here again, permutation. In biology, you have a concept called mutation, right? Mutation. So the fundamental question that we have, this will be question 1 for this lecture 4. What is permutation? What is permutation in mathematics, right? What is permutation in maths? What does it mean, first of all, in maths? What is it? So there are so many definitions or so many different sources that have defined the terms permutation, but one of them is this permutation. Permutation, we say that permutation, this is a way, or is a way of, or is to say that is arrangements of the way. So permutation is a way of arranging, is a way of doing what? Arranging different objects, right? Different objects, whether in circular or in a line, okay, in which order of arrangement, it means order of arrangement is taken into consideration, is considered, or is taken into considerations. Let me just shorten the sentence. Is considered. And I will tell you consider, because these definitions, this sentence will differentiate permutation from combination. I believe that you enjoy the beauty of engineering and scientific mathematics, and tell me in the comment section. So say permutation again. Permutation is a way of arranging different objects, right? In which, so this is the way of arranging different objects, in which order of arrangement, the order of arrangement is considered. That remains a 40 of permutation. Okay, so if this is the case, say that this is the arrangement of 40, arranging different objects, in which order of arrangement is what is considered. So what does it mean? Okay, we say that, for example, okay, we say that, for example, let us arrange two letters from groups of, okay, example, we say that, example, arrange, okay, two letters in the word A, B, C, okay, in order of A, B, C, where order is considered. So we have how many? We have to arrange these two, we have 3 letters, A, B, C. But you have to arrange your 2 letters from the arrangements of word A, B, C. So how do we arrange them? So listen. So it means that permutation now. So the permutation for this case means that the way of arranging, we can have A, B, can have B, C, can have AC, we can have BA, right? We can have also CB, we can have CA. So there are 6 ways of arranging 2 letters from the radio to A, B, C. Okay? So when you say order is considered, what does it mean? So you say that order is considered. What does it mean? So the meanings of this sentence that order is considered is AB, this is not equal to BA. So these are the 2 different arrangements. You have to listen carefully because I will explain also this concept in what? So I will explain also this concept in combinations. Also, we say that if you refer this example, so this is example 1, let's say, if you refer example 1, so it means that AB is not equal to BA. And also we say that BC, this is not equal to what? For permutation, right? So order is considered. So this is the meaning. So order is considered. So BC is not equal to CB. So these are 2 different ways of what? Arrangement. While also this is 2 different ways of arrangement. Also, we say that in AC, this is not equal to what? CA. Also, this is what? 2 different ways of what? Of arrangement. So then that the process and that the fact that it has been going through, and what we have to say that we have to keep that in our mind. Okay? So we have I think that we have 3 types of permutation. So we say that in mathematics we have 4 ways of arranging, or we can arrange objects either in a line, or we can arrange objects in circular, or we can arrange arrange digits. Also we can arrange words, letters of the word. So we say that in mathematics, we say that we can arrange the following. Okay, we can arrange the following objects. Okay, first of all, we say that we can arrange objects. Okay, we can arrange objects in a line, and this arrangement is n factorial. We just use the factorial that I told you. Also, we say that we can arrange objects in a circular. So in a circular depends. You can find that we can have n factorial over n. This is the common formula. Okay? So n factorial over n. For example, that Olenjolaim and his family, which consists of 5 members, want to sit in the round table. So how many ways that we can rearrange ourselves? So first of all, I have to fix 1 member of the family. And then others we have to rearrange with respect to that 1 member. So that the one that we fix, we can fix either among the 5. So that's why we have n. So n factorial over n. But also you can arrange what? You can arrange digits. So you can arrange digits in particular order, right? Digits not in a line also. Okay, in a line means that in sequence. And also we have a first possibility. You can arrange what? Letters of what? Of words. So of words. And this is all about permutation. Even these arrangements of the digits, this is permutation. And this also is all about permutations, which I'm going to teach you soon. Right? Okay. If you have any question, don't hesitate to ask in the comment section below, so that I can help you as well as I can. So then that's the concepts of permutation. So let us go to more. We know that when we've been teaching you basic mathematics form 1, basic mathematics for the form 2, basic mathematics for the form 3, basic mathematics for the form 4, and basic mathematics for the form 4, we have never taught you about the concepts of permutation. Unless that you are from you are ordinary diploma, but you passed to advanced educations and you study mathematics or basic applied mathematics. So let us look about permutation. Say permutation of n objects. So you say that if you want to say that the n permutations of k different objects from the groups of what of n objects. So you say that if n objects or if k objects, right, if k objects are selectively from n objects, okay, in order to be arrangedly. So if k objects are selected from the n objects in order to be arranged in particular order, where the order is taken into consideration. Where the order taken into consideration. So this means what? Consideration. So this means what is permutation. So this we want to reduce the general formula of permutation, right? So the general formula of the permutation. So you say that then the arrangement of n objects, okay, n objects in order of k is given as n permutation k. So this P should be capital letter n permutation k. Okay, so if you join me right now, you're on the welcome, you're on the welcome, you're on the welcome, you're on the welcome, you're on the welcome. So you say that n permutation k, this is pronounced as n permutation k. So we say that generally in maths or in principle of counting, we say that we can find n permutation k as what? This is n factorial divided by n minus k, then what? Factorial. So this is the general formula of finding n permutation. So n permutation k is equal to n over n factorial over n minus k factorial. Or in some of the books, instead of k, they use r, so n permutation r. This is equal to n factorial. Then here denominator, we just take n minus r, and then we multiply by what? By this factorial sign. And we can prove it, because how many ways of arranging two letters from the word ABC we have? So you have 6. 1, 2, 3, 4, 5, 6. So you can prove it if it is true. Okay? Because the permutation gives us the number of ways that we can arrange n objects. Right? That is. So give us the number of ways that you can arrange n objects. So for instance here, n is the number of objects given, and the k or r, that's the number of objects that you arrange them together in that particular arrangement. So for instance, for this one, right, for example 1, we say that n, how many objects have been given? So I've been given 3 letters. So n is equal to 3. Then we need k. K, how many letters do we arrange them? We just arrange 2. So then from the formula, we say that n permutation k. This is equal to what? N factorial of what? N minus k factorial. So this, okay, n, what is n? So simply n, this is equal to 3 permutation k, and this is equal to 3 factorial, divided by what? 3 minus 2 factorial. So just simplify. So in numerator you have 3 factorial, in denominator you have 3 minus 2, which is 1 factorial. Then 3 factorial over 1 factorial, so what do you get? So you get 3 times 2 times 1 factorial over 1 factorial, so 1 factorial, 1 factorial, and I get 1 factorial and 2 factorial. 1 factorial, 1 factorial cancel. So 3 permutation 2, this is equal to 3 times 2, which is equal to 6, and it is true. So, you know, with this method of arranging or listing, because this is the method of listing, so you've been listing, so this is method of listing. This is possible if you've been given few objects, right? You've been given few objects, like 3, like 4, like 5, maximum I think that's 5. But what if you've been given 10 objects, or you've been given 11 players of the particular team? Then you have to arrange them, maybe they have to sit 5 by 5. So how many ways that we have to arrange them. So it means that it's a little bit difficult. That's why we need the general formula. Because with this general formula, now we can deal with the problem. Right? So make sure that you remember this for the rest of your life. If you have any question, please don't hesitate asking in the comment section. Okay. Okay, so then if that's the case, we can even have some few examples. Okay, so let's continue. So I believe that now you have understood the concepts of permutation. In case that you find you didn't understand, make sure to watch this video several times until this concept is clicking your mind and remaining there for the rest of your life, and even you'll be a good teacher of your children and your grandchildren. So this will be example 13, and I would like just to say that to give you some simple examples. So this one also you have to refer. So let us refer. You have to refer one of the tutorial sheet right? Tutorial sheet. So tutorial sheet, and this is question 15, right? Question 15. Okay, so question 15, very interesting. Have to enjoy the beauty of basic engineering and scientific mathematics. Okay, so the question asks us to evaluate. We've been given 3 values, right? How to evaluate what? How to evaluate Roman 1, 60 permutation, 60 permutation 4. And then Roman 2, we have to evaluate 60 permutation. This is Roman 2, this is Roman 2, Roman 2, Roman 2. Okay, tell your neighbor, understanding is coming, understanding is coming, understanding is coming. 60 permutation 2. And then 3, it's not listed in Romans, but they want to list in Roman. You have to find n permutation 0. Wow! Very simple questions because I've told you. Okay? So B stands for permutation. Remember that. So solution. Solution. So solution, the first step, we have to say that let us recall the general formula of permutation. Okay? What is the general formula of permutation? Formula of permutation. Tell your neighbor, if you join me right now, you want me welcome. I'm teaching you the beauty of permutation today in this lecture 4 of what the principle or rule of counting. So the general formula, we say that n permutation what? K. This is equal to what? N factorial divided by n minus k, then factorial, right? So for Roman 1, we have been asked, we have been given to look for 60 permutation 4. So 6 permutation 4, what does it mean? So this is corresponding with n permutation k. What does it mean? N is equal to 6, k is equal to what? K is equal to 4. So if that's the case now, we say 60 permutation 4. This is equal to 60 factorial. That's why I taught you factorial in lecture 1, lecture 2, and lecture 3. Then we have n minus 4, which is 60 minus 4, n minus k, what is factorial. Then you do a simple basic operations here. 6 minus 4 is equal to 2. So of what? 2 factorial. So next you say 60 permutation 4. This is equal to what? 6 times 5 times 4 times 3 times what? 2 factorial. And then this of what? 2 factorial. So this one and this one will cancel, right? Okay, so if this is the case, there are 60 permutation 4. This is equal to what? This is equal to 6 times 5 times 4. You have to use your scientific calculator, or you just basically do it because you're good mathematician 3. So it means that 60 permutation 4, this is equal to what? Okay, 4 times 5 is 20. 20 times 3, okay, yeah, it is 20. 20 times 6 it is 120. 120 times 3 is equal to 360. This is it, 360. Why? Because this is 30. 30 times 4, it's 120. 60, 60, 120. 120 times 3, it is 360. So that's the response. So let me just write it this one clearly. So therefore, 60 permutation 4 is equal to 360. That's the end of solutions 40 for Roman 1. So try this one yourself. Try it. Try it yourself. Let me do for Roman 3. Pause the video, try to look for 6 permutation 2. And then tell me in the comment sections if you manage to find it. In case you fail, let me know because I'm here to help you. Okay, so then Roman 3, we have response to find n permutation 0. So n permutation 0, usually at the first state. So because you said that this it mean the first state, then okay, we call this one, and then we say that this is the second state. So we say that evaluate what after having that one, evaluate 60 permutation 4. So the first state, we have to recall the general formula. General formula. I will be teaching you to solve problems of mathematics by following what is steps. Formula 14 of permutation. What is this general formula of permutation? General formula of permutation, we say that this is what? Say n permutation what? K. So n permutation k, this is equal to n factorial, and then divided by what? N minus k factorial. Okay? At the general formula. So from this fact now, we say that we want to solve for n, so it means that so you can say that let us evaluate what. So let us evaluate, so suppose that, okay, let us evaluate n permutation 0. So to evaluate n permutation 0, n is equal to n, and k is equal to 0. Remember that you can either use k or r. So you should not be confused with that concept. Okay, so then if this is the case now, we think that we are looking for n permutation 0. So n permutation 0, this is equal to n factorial over n minus 0, then what? Factorial. Wonderful. Then in numerator we have what? N factorial. In denominator we have n minus 0, which is n factorial. So then this one cancel. So n permutation 0, this is equal to 1, and that's the response for this question. Interesting. Very interesting. Okay. So again, the next concept after you know now to evaluate the permutation, okay? To evaluate the permutation of these values. So before I take you into some a little bit expressions of permutation, let me just need to teach you again another concept. It means that this is the concept of finding permutation. Finding permutation of what? Of objects, of finite object, finite of objects, right? By using scientific calculator. By using scientific calculator. How we can find permutation of the objects by using scientific calculator? That's the question, right? So we say that, okay, we can use scientifically, because I want you to be competent, scientific calculator. For instance, that one recommend Casio FX 991 MS, okay, to find permutation. Find permutation of 40 of objects, of finite objects. How we do that? Take your scientific calculator, and then I'll give you steps to follow. Simple steps that to follow. Okay? Take your scientific calculator. Yes, you have a few steps to follow. You may take mine, so even yourself take yours, so that you participate. actively. Okay, so here is our scientific calculator, which is one of the weapons in learning basic engineering and scientific mathematics. And we really ask you that in case you don't have this weapon, you can order online Diploma Polytechnic Institute of Tanzania. We are also equipping our students with the materials. And one of the materials that we are equipping them is scientific calculator. This is the one of the original scientific calculator. We have also some different models or different products. So to just to find the permutations, first of all, you have to examine some few functions that you have to be familiar with. The first function is a functions, this one, the functions of shift. We are going to use this function of shift. And the second function is above the multiplication sign x, right? Above it, there is n permutation what? N permutation r. Okay? So in scientific calculator, we just need two buttons. Okay? So number one, so we are going to use two buttons, right? Two buttons of 40 of scientific calculator. The first button is on the top left side, which is it has been drawn in this form, and here at the top of it there is words which there is a word written as what shift. And then the second button is on top of it. It has been labeled as multiplication, but on top of it there's also a word or a function that written as n permutation r. Right? So simply it means that here we need to use a function called the shift, and here we used to use n permutation r as the permutation function. So what are the steps? So the second step, we say that press what? First of all, we say that insert the value of n. So I said the value of n, for instance, in the previous example, n is equal to 6, right? So insert 6, number 3. Then we say that press shift, then what? Then followed by what? By n permutation r button. So we say that we had what? Our value of n is what? Is 6. So insert 6 here. After inserting 6, you press shift, then you press this symbol. So you have permutation now. So when you do this process, then so you have 6 and then bolded permutation. So if you have this in a scientific calculator, then you are in good position. So then what is our R for the previous example? That's example 13 over 1. R, it was 2. It was 4. So it means that we put 4 there. So just write the number 4. And then, so you have now, so this is the way that it has to appear. This is 60 permutation 4 in the first row of scientific calculator of this display of the scientific calculator. Then this is 6 permutation 4. So you press the equal sign. It is what is 360. Right? So 360. So it means that now 60 permutation 4, this is equal to what? 360. And it is true. So if the value of k and n is known, then we can find its permutation by using scientific calculator. So it will be minimizing too much toil or be toiling on multiplying so many numbers when you can use your scientific calculator, right? So I have a question, and this will be example 14. And this question also has been given in tutorial sheet. So refer tutorial sheet. Question what? Question 16. I have the soft copy of this tutorial sheet, so I can share with you if you want. Use scientific calculator. Use scientific calculator to evaluate what? Command 1. 16, permutation, 7. And then command 2, we say that be given 25. You see that now these are large number of objects. So in command 1, we'll be given how many objects? 16. For example, this 16 is representing the number of players for Simba Sport Club, for Manchester, for Barcelona, for Liverpool, for Real Madrid. So it means that only 7 players, they have to be selected because they have to be or arranged 16 there is a bench which accommodates only 7 players, right? So how can you arrange these 16 players to sit on the bench? That's how combinations is coming into play. So it means I need 3 bench of which accommodating 7 players. However, that the same bench will accommodate only 2 players because 14 players will be accommodated in the first 2 benches. So dealing with this one, for example, that if you want, let me show you the challenge. So why should you use a scientific calculator in this case? So the challenge, why do we need a scientific calculator for the large number of objects and even arranging them in the large number of orders? Because it's a challenge to use a formula to solve this problem. Why? Because if you have 16 permutation 7 and then you want to use a formula that which correspond to n factor permutation k or n permutation r, so here it will be n factorial over n minus r, length in bracket factorial function. So this is 16 factorial, so it will be 16 factorial, and here we have 16 minus 7, it will be 9 factorial. And then if you do multiplications, you find that 9 factorial, 9 factorial, and this is the multiplications of 40 of the values. So you find that taking 16 times 15 times 14 times 13 times 12 times 11 times 10, it's a lot of 40 cube manually. So now can you think about this 25? Because it will be 25 factorial over 20 factorial. So you have to take 25 times 24 times 23 times 24, 2 times 21 times 20 factorial. At least you cancel out the factorials. But we have actually the large numbers that we have to multiply them. So that's why that we prefer to use a scientific calculator in order to simplify this way, this kind of way. Okay, so if this is the case, we say that now there is a scientific calculator. So we have number 1. So you have to find what 16. Okay, permutation of 40 of 7. So this is solution. 16 permutation 7 by scientific calculator. So the first step I told you, the first step, if you remember, you have to insert what? Insert 16 in what? In scientific calculator. The second step, I ask you to do what? Press what? Press shift button. Shift what? Shift button. Then press what? Then press N permutation R button. So then press N permutation R button. Right? Next, what happens on the display? On the display of scientific calculator, you will see that you have what? You have 16, then body P. So you go forward and you set the step. Set the step, you have to also insert it. Insert 7 in what? In the scientific calculator. So right now on LCD, that's the LCD display, you will see 16 but the permutation of 7. And then next is the fourth step. After you have it, you say to press what? Press equal sign button. So to press equal sign button, then what you are going to have. So you have to take your scientific calculator. Let me show you how we do. Number 1, what the value of n 16, insert 16, we have inserted 16. Since we come that shifty, then we come to n permutation R button, which is x on top of it. Then we have what? The value of R, it's what? 7. So you press the equal sign. So the answer is what? 57,657,600. So now we say that because we write it 16 permutation 7, therefore 16 permutation 7, this is equal to 57, and then we say that this is 60, 57, and this is 600. Okay, so 600. So similarly, for Roman 2, you do the same. Should I leave the Roman 2 for you to try it? Yeah, it's better if I leave it for you to try it. So try it yourself. This is try it yourself. Very simple. 25 permutation 5. Very simple. Okay, so then that's example 14. I'm about to end this session or this lecture. Okay, so let me teach you example 14. Say example 14. So let me teach you example 14. And also this you have to refer what tutorial sheet. Tutorial sheet. Question, and this is DIT tutorial sheet, but you can find it in other institution. So question 17. Question 17. Find the value. So the question says that find the value of n given that command A, this is n permutation 2. This is equal to 30. Then we have B. We have n permutation. So you can find that some of the typing challenges of typing this superscript and subscript. So 10 n minus 1 permutation 4. But you should know. You should understand that P stands for permutation. It's a universal sim. So this one will be homework. What? Homework 4, right? So this will be homework 4. You have to do it and submit in the comment section. So I have to do it. I have to do Roman 2 for you to show you the way how you can find the value of n. So because Roman 1 is the simplest one, more than Roman 2. So let me do the challenging and then you do what the simplest thing at this moment, because I'm still building the foundations of permutation. We'll still have also another session on forte permutation because we didn't touch permutation of the words. We're not going to teach about permutation of the words and solving permutation or solving some permutation equation, right? So it says solution. So what we've been asked to do as mathematicians, find the value of n in this given expression. So you have to find the value of n. 1. So we have two sides. So first of all, we say that we have n permutation. So because you are writing on your hands, you can write now like this way. So in this one it is 10, then n minus 1, then we say that this is permutation of 4. Right? So if that's the case, we say that, so suppose that this is question 1. So let us go first step. So the first step, consider left hand side of 40 of equation 1. So if you consider left hand side of equation 1, we have n permutation 2. But this should be the second step. Excuse me, second step. The first step, we have to recall the general formula. General formula of 40 of permutation. So you use either K or R, so I'll use them interchangeably. So n permutation R, this is equal to n factorial over n minus R factorial. So if you consider on left hand side you have n permutation 2. So just substitute. So n permutation 2, this is equal to what? N factorial, and then here we have what? N minus 2 by 20 factorial. So suppose that this is equation 2. Then you go for the third step. The third step, we say that consider what? Right hand side of 40 of equation 2. So to consider right hand side of equation 2, here we have what? 10, then times what? N minus 1. Then what? Permutation of 40 of 4. Okay? So with this one, we have our general formula, which is n permutation R. So this is n, so this expression is value of n, and this is R. So you can say that 10 n minus what? N minus 1 permutation of 4, this is equal to what? You can even set 10n minus 10, and then she said that this is permutation of 4. So 10n minus 10, right? I'm not sure if it was, I wonder that this 10, it's a coefficient, not the multiple. Yeah. So it has been written as 10 like this way, right? But you have to understand that this 10 is here. It's a multiple of this expression. So make sure that you note it. So this 10, because I know the challenge that we are going to encounter. So this 10 is here. So it is 10. So even we can do like this way. And this is what? 10. So this is 10 times 10. 10 times n minus 1 permutation 4. So you can keep on having 10 outside the bracket. Then you have n minus 1 itself, permutation 4. So apply the general formula. So to apply the general formula, this is n minus 1 factorial divided by n minus 1 itself, then minus what is the value of r, which is 4, hence factorial. Right? So let us keep on simplifying. So it means we say 10 n minus 1 permutation 4. This is equal to what? The numerator is n minus 1 factorial divided by n minus 1, open the bracket, okay, minus what is n minus 1. So numerator you have n minus 1 minus 4, what? Factorial. Right? So this will make what? So this will make n minus 1 factorial. And denominator, we have n minus 5 factorial. Right? So n minus 5 factorial. Okay. So n minus 5 factorial. That's the right hand side. So this one, with these questions, let's write this is the concept. Because I see some concept that is coming along there. So then the next step, because you have to find the value of n, it's very interesting. Okay, so you have this expression. So you have to, so you say that this is 10. So okay, so here it is, so this is 10, and here we have 10, right? So 10, but this is 10, n minus 1, permutation 4, is equal to it, is equal to 10 times upwards. So this one will make it in equation 3. Okay, equation 3. So afterward, we have equation 2 and equation 3. Do not what you have to do at basic engineering and scientific mathematician. We have to equate. That will be the first step. The first step of solving is that take equation 2, equate to equation 3. So what is equation 2? On the right hand side of equation 2, this n factorial over n minus 2 factorial. This should be equal to 10. Then you have n minus 1 factorial divided by what? N minus 5 factorial. We have to find value of what of n. So this will make equation 4. Right? Interesting. This is the beauty of basic engineering and scientific mathematics. So for this case, we have to go back on lecture 2 and lecture 3 to see the relationship between, because here we have factorial function, factorial. There's a close relationship. One factorial function is a subset of the other. So this one is a subset of this. If I expand this one, I will get this factorial function. Also, this one is a factorial of this function, right? So there's no way out that maybe you can cancel. So the fifth step, we say that let us simplify. Simplify what? Let us simplify equation 4 above. How do we simplify? So in numerator we expand n times n minus 1, and then times n minus 2 factorial. Hence on this side we have n minus 2 factorial, right? On the right hand side we have 10 times n minus 1 times n minus 2 times n minus 3. Hence we say that times n minus 4 times n minus 5 factorial divided by what? N minus 5 factorial. Our aim, we want to simplify. So this one and this one will cancel. Again, this one and this one will cancel. Right? Good. So now we have another expression. So you see how mathematics looks like. I believe that you enjoyed it. Again, in case you want to offer God, our God who is in heaven, who reigns there and heaven, you are free will in thanksgiving for God bringing this knowledge in your house, in your car, in your regions, in your city, in your college, free of charge. Because these are the worth contents. If I could charge you, could have to pay a lot of money. But God has been faithful that He asked me to offer my own thanksgiving because on the gift of teaching. Make sure to send your free willing thanksgivings on this mobile number, telephone number, so that you'll be supporting the running cost for more sessions of basic engineering and scientific mathematics to be in air through the internet to help present and future generation. Okay, so if you check on the left hand side, we have n, then we have n minus 1, that's all. And then on the right hand side, we have what? 10, n minus 1, n minus 2, n minus 3, and n minus 4, right? That's all. So it means that you can cancel this and this, 10. So this n of n is equal to 10, n minus 2, n minus 3, and also n minus 4. So what's our responsibility? To find the value of n. That's what we've been looking for. Find the value of n, that's what we have to say. Say, okay, n is equal to what? Is equal to 10. Then so you can expand n times n squared. Then negative 2 times n, negative 2n, and negative 3 times n is negative 3n, so it's equal to negative 5n. Negative 2 times negative 3, this is equal to positive 6. Then so this side n minus 44. So again we have n is equal to 10. So let us expand. N squared times n, this is n cubic. N squared minus this one times this one is negative 4n squared. Then minus what is, so here we have minus 5n squared. Then so you have 20n. Right? You are done. So then you say that plus 6n. 20n, okay, plus 6n. Hence you say that this is minus 24. So you say n is equal to what? So collect the like terms. N cubic itself, right? Then n squared, this is makes what? Minus 9n squared. And then so you have what? 20 plus 6n, this is makes 26n. Then so you have the constant term, which is 24. So multiply by 10, right? So this will give us 10 n cubic minus 90 n squared plus 260 n minus 240. So we still have another n on this side. You can bring all of these items on this side. So if we bring them on this side, we say that we can bring, let us bring n on this side. So we say that let us n minus n, the simplest way, n cubic minus 90 n squared, and then plus what? 260 n minus n minus 240. So this will make 0. 0, this is 10 n cubic minus 90 n squared plus what? 259 n minus what? 240. So for that case, we say that 10 n cubic minus 90 n squared plus what? 259 n minus 240 is equal to 0. And this will make your question 5. So you understand that I asked that let us call this a conceptual question, because it's interesting. This is from tutorial sheet for this module. Okay, so then we go for this will be the 6th step. The 6th step, we say that solve the equation, what? 5. By using a scientific calculator, right? Because this is a cubic function. So we are solving 40 for the value of n. So just take your scientific calculator, let us go together, press mod for the first time, press mod for the second time, press mod for the third time until you see equation. So choose the equations by pressing number 1. There we are solving only 1 unknowns, not 2 unknowns, or neither 2 unknowns nor 3 unknowns. So you press this. How many degrees? Is it 2 degrees? The highest degree, is it 2 or 3? The highest degree is 3, so I have to choose 3. A is the coefficient of n cubic, which is 10. B is the coefficient of n squared, which is negative 90. Then C is coefficient of 40 of n, which is 259. Then D is the coefficient of n power 0, which is negative 240. Then you get the answer, so we have to wait. So the first value of n is 4.165. The second value of n is 2.131. The third value is 2.704. So we're being asked to solve for what? For n. So we say that therefore we can prove the values of n are the first one 4.165. Just you put your answer in 3 decimal places, and then say 2.161. Then we have the other ones. It is 2.704. Yeah. So these are the values of 40 of n. So make sure that you do the example, 14? This example, yes, kind of example 14. Roman, exam 14 or exam 15? Exam 15 exam 15, Roman 1. So make sure to do before you move into the next lecture. This is the end of lecture 4, the general introductions of permutation. I thank God who have been with me, who have created me in his image, his likeness. He gave me the gift of teaching. He loves me. He gave me lives. He gave me this great idea of teaching national and international students for the present and future generations. He has been faithful in my life. And I thank you a chance to be with me. And I thank God who have been faithful on teaching of this program. And I thank God because I believe that He's going to give you a chance to learn with me in the lecture 5, where that we'll be learning some other new concepts of permutations and solve some more challenging questions so for you to be competent. Remember the vision and the main goals of Online Diploma Polytechnic Institute of Tanzania in square bracket OLENJOLAI is to see you solving real-life problems, even a small scale or medium scale real-life problems from your community. So this is the end. I thank you very much. I remind you, in case that you want to offer free willings as well, tell us in the comment section whether you have understood us or not. And then if you have understood, you have to give God all the glory and all the praise, because He's the one who taught you through me. He's in me, and He's the one that's teaching you right now. Remember to offer your free willing thanksgiving to Him, okay, to Jehovah, and there's also the telephone number 0759 34 5331, and your free willing thanksgiving will be received with the hands of saints. Again, remember to subscribe, share these contents, read the descriptions to get more information, and then try to learn and even to go beyond of what I taught you. Make sure to go through, you review this video several times as well as you can until these concepts click, until these points click in your mind. And also make sure that you are active students and you are very serious in these programs, because you are very serious. Don't miss to attain your classroom sessions with your former teacher, which I call them possibly it might be physical session or analog session. Make sure that you attend, you grasp some new concept which has been taught there, you combine with what I'm giving you in order to go far as well as you can. So I thank you very much. I'm praying for you, keep on praying for me, so that God to be faithful in this business, and then we achieve the main goals of this program. So may God bless and keep you safe until we meet in the next lecture.